Hello. So after training the first model, just a brutal attempt to see if we can have some indication that the end-to-end thing works. Let's hide OBS. So it trained, the losses are chaos, but okay, it doesn't that much. I was expecting just a null prediction, to be honest, because I didn't do that much of anything, just calling fit, but it wasn't. It was bad, but not that bad. So at the end of the training, I just was saving the model, and then I have a small model evaluation thing in which I load the trained model, just predict using the threshold in the sigmoid, getting the true values. The F1 score is around 0.55, so clearly it does not work. It's not really good, the model. But if we see this is the true and the predictive values, there are some indication that maybe it's actually learning something, but okay, of course, there are a few things to be made. The first thing I would like to do, at least, is removing these strange events that we have, the really long ones. I'll let to remove that because in some cases it can span for like 11 hours, so basically half of the data. And then we should start iterating with the model. Then what I would like to do at some point is to, since these are overlapped window, for a single study there are overlapped windows, I should be able to reconstruct the events, maybe just making an OR between the two overlapped samples. If there is one in of the prediction, put in one. So I should do that, should do this, but first, since at least we have the whole thing working, I would like to create our prepared data set like properly with as a script, and a script that can be called from the command line to create our data sets. And one thing we need to do also is to indicate our threshold of events to discard here. So max length event, it will be an int, and maybe we can from here remove, I don't know if it's still present, the dataset creation. Probably not. Okay, perfect. So we should, in the prepared dataset, get the configuration for knowing where the dataset is, getting the list of studies. Maybe this is a thing we can just remove from here. Okay, yes, because it will be in the ETA. Let's keep the repeated indices in here, just in case for JSON. We can remove it also from here. Maybe we can create a function for this. Def remove repeated studies. We can just return this. Study list will be a list of paths. Okay, chill. Python is enable, blah blah blah. From typing import list. From badlib import path. So we are getting the study list, the data path. We're just trying to see if there is this file. If not, we can recreate it. We open it and we just clean our. So we have this. We have this. Remove this, remove this, remove this, remove this. Then we can. Oh, in the configuration we have. It was commented. Okay. In the configuration we have all the information we need. We should be able to, when we train the model, to read the configuration. So okay, it's wait, let's put some okay, let's copy this. Let's put some default values, and we are missing now the max length event and max length config. Then we can just prepare data set with the configuration, and then we can just logger data set saved in the path. Let import logging. Logger is this thing. Okay, and then probably we should use typer. And okay, then we're going to adapt here the code. Maybe we can do config load config, and then we can just do something like this, but let's implement it later. So we have the, okay, let's use typer. Let me close this. Typer. Let's clear here UV typer numpy. Okay. And I would like to use the resources learn the option thing, so we can have something like this. Let's copy that. Prepare data set. Maybe, okay, let's see if we can just do something like this. Copy the imports. We have, so first of all, input path. Can I use path in here? Who knows? Okay, let's put it as a string, then we can resolve it. This is so do I need the input path? No, because it's going to read it from the configuration. Yes. Maybe just output path, but the output path is being used? No, because we are saving it here, so probably I don't need this. Maybe if I want to call like a data set ID or something like that, in case I want like a description. Okay, let's go with the other one, the thing that we know for sure. Train proportion, this will be a float. Train proportion value between 0 and 1. We have the val proportion, train set, validation set, sliding window size in samples, sliding window stride in samples. It's not absolutely not clear the comment, but I don't care. And this should be also int. This should be int int maximum letter and event. This is in seconds. Okay. So maybe we can just put everything in here. And I should, how do I use it in typer? Should I annotate this? Typer run directly. Okay, typer run main prepare data set. Train proportion. Maybe you can do some checks. Exactly. Okay. I think that's it. Let's keep it simple. Maybe I can see. Okay, let's add max workers annotated int default for. I think it's just like this. This is max worker. This is the show progress. Okay. Show. Can I do an optional? Let's keep it in true. Show progress equals show progress. Let's format everything. And then, okay, let's suppose this thing works. I should in the Py project project script. So this should be prepare dataset. This is the model, right? Ph set dot CLI prepare dataset, and I should and then the function main, and then we can just def main exactly here main. Let's see if I do uv pip install run. Maybe we can do something a bit more just to be sure. uv run ph set prepare. Can I do like this? Okay, not bad. So okay, let's see if we arrive until here. Raise value error. Train proportion 0.8, bar proportion 0.1, time window length, I don't remember. Maybe I can use in second everything, window stride. I think I will do it in only everything in second. It's going to be much easier. Just a number. Max event length 60, 120, show progress, max workers 3. Max length, oh no, and off. Okay, so what else? We should use this thing at some point. Maybe let's use everything in second, so at least it's going to be easier. So let's go to window length So if this is in second, I should multiply by 50. So I put 2 minutes. No, I put not 2 minutes. I put 2 seconds. It will be times 50. Okay. So let's, with which value did I use before? Okay, 2,500, 200, 20. Oh no. Okay. Chill. This should be 50 seconds. Okay, maybe you can put a minute with a half a minute of overlap. It shouldn't be that bad. So let's put here 1 minute. Is it too short? We can do 3 minutes will be so when we saw in the ETA was there was an error. No, maybe it's the 60. Maybe we can use 2 minutes to include all of this, just in case. Okay, even until here we are probably covered. So let's try with 2 minutes and 1 minute overlap. 1 minute overlap, it's okay. We can try. But the other thing I would like to do is in the prepared data set, when we are calling, here in some moment we should create the processor. Where the processor is created? Here, exactly. So here will be a max length event. We are going to use something like this, a target column. Let's add here the max length event. Let's format it. A target column, let's put a max length event. This is always in second. Let's convert it at the beginning. Okay, if event.length is greater, continue. Exactly. Let's do. I have the docstring thing installed. No, let's install it. It's going to be useful. Preferences extension, docstring. Yes. No, oh, come on. Add a binary column to G times it again the pressing of the event. Threshold for the event. Even though it will be ignored. Information about the study. Time series data. Time series data with target column added, something like that. Okay, not that bad. Okay, and we convert everything to samples at the beginning. So in the prepare data set here. We do exactly the same here. So we just use this times 50 and any event longer than that will be discarded. I was thinking of using, according to what we saw here, around 200 seconds for, no, at least around 300 seconds for discarding. So we discard everything of this, and a bit longer that I saw they were a bit strange. Let's try to remove that from the beginning. So we have 2 minutes. I don't know what to put here. Let's do 1 minute. Who knows? If there are longer than 300 seconds, let's discard it, because in this case also the event will be split in many windows. So I actually. So the problem is having the, I don't know if we should changing how the splitting is made, being sure that, no, but being sure that the event is always complete, but in the real world I will not know where the event is. So I need something like this. Okay, little by little. Let's go. Exactly. We were thinking really ahead, and I missed a parameter. Max worker. This is max workers. Okay. This is too fast. It's not working. So one thing I should have here is the thing. Let's put no, not let's something like this. Not logging. Something like this. How can I? Okay. Was fitting. Maybe it was working. It's a bit too fast. Okay, let me kill everything. Let's do like this. Data. Let's remove everything that is in here. We can start over. Are we saving the configuration? Yes. Okay, then we can add a load. Well, we receive a path. Okay, perfect. Let's remove everything. Let's kill here. Okay. Oh, I have to write. Okay, thank you. We have 60, 300 show progress. Let's copy this in the README. Dataset preparation. I don't know how to do backticks in this keyboard, so I won't. So it's going to be, is it going to fit the, maybe I can put some logs. Okay, this is going to prepare it in fitting preprocessor. Tuki, creating the dataset, tuki. For future, can I know if this fails somehow? Probably I should be able to. Can I ask compiler here? How can I the future ended with an exception? Not bad. Feeding preprocessor 75, 9 and 10. Then when we are finished more or less with the training thing, we can move it to a script and do a better model train. You can store it in folders and then comparing them instead of running in a notebook. Is this working? So this is the path. Let's see. Okay, it's working. So I will leave this thing running and then later try to see if we can load this data set and keep iterating over the model. So in the previous video we were able to create a data set at least using TensorFlow, and we stored it in disk. So now I think we are ready for training it. I did some test on my own, at least to see what's going on. I have a notebook just with some hard-coded architecture there. A training I try with some different way of trying to balance the data set. I tried a few things. Then I saved the model at the end. And then a model evaluation notebook, which basically loads the data set and predicting the test. And the results are a bit terrible, but okay, that's something that I was expecting since we haven't done anything yet. Then, so we have this prediction. I would like to do now is, okay, trying to clean up a little bit the training procedure so we can actually do some experiments and tracking the experiment and try to see which things works better. And then probably we will need some post-processing of these predictions to try to detect continuous zones of positive prediction to define the limits of the events, and then trying to evaluate the metric of that post-processed events. To have an idea of how well these events are being tracked, and probably using something like the intersection over union of the event, something like that. But yes, and okay, and I think for starting, I would like to try to make this script. This is a notebook, trying to put it in a script and make it a bit better. This thing more with parameters in the architecture and everything. And at some point I would like to try to not only this simple architecture, which just are basically convolutional layers one on top of the other, and I transform then so I'm decreasing the dimension and then increasing it, and having just one output channel for the sigmoid, but also maybe trying to implement something like this, which basically like the UNet, but for time series. They use it for detecting events in the sleeping, in a person sleeping. And the architecture is, I think there's a graphic in here. Where is the graphic? The architecture here, which are basically convolutional blocks reducing the dimension, convolutional transport for increasing the dimension, but with the skip connection between each of the steps. So at the end we have the U shape that's in the UNet paper. The UNet, no, is the name. UNet segmentation. Oh, but it's in Wikipedia already. Exactly this. We have the skip connection in here as the same thing as in here, but of course not in images, but in time series. So I was thinking of having two architectures, one simple and this one. They're going to be the same with or without the skip layer, the skip connection, with some parameters, and then try to see how far we can reach with this. For now, I think here in the output they were using like multi-class instead of just one thing. Maybe we can actually do it later, trying to classify the content of the thing that is being returned by the stomach. Maybe we can classify the content instead of just something is going up. But okay, for now, let's start by trying to refactor this a little bit. We have here, let's call it train.py. If name it's equal main, we can use, let's call it main, def main. This is for the PyProject TOML, and then we have main train, and then we will put some, for example, the output path. I'm going to copy it from here. Do I have another path? No. Okay. Now maybe I don't need an output, but I will output everything in here. Maybe the data set ID, which is our timestamp of the data set creation. Data set identification of a string. The model will be our timestamp. Maybe we can have some name in the model. Maybe this will be optional. And we have the dataset ID. We have get config and load config. Okay, this is the data set metadata. Data set metadata as how big is the window, blah blah blah. And then I would like to create model. Model.py. Build model, everything is called model. I don't like it that much, but let's see later. We have our text window length. Let's for now just hard code the 7 here, but maybe we can change it later. And let's create from Pydantic import-based model configuration. We have com layers. Let's put it like list of ints. Let's put like something like class filter kernel size stride. Let's keep it a bit more simple. Com layer, and this will define the opposite. And can I define skip connection. Let's see if we can do something like this. Let's receive the configuration. Well, maybe we can put it in here. Input length, conf model configuration. Let's do like this for. And let's write x equal input. Let's use reloop, adding same stride kernel size filter. Probably maybe we can add. This is the convolutional patch normalization, convolutional patch max pooling. So maybe we can remove the stride. Well, let's create the most complex one, and then maybe we can. So let's remove the stride. Oh, let's put some pooling. Maybe we can call it block pooling size. Com block. Convolutional blocks. We have the convolutional, the batch normalization, another convolutional, no, the color right, another batch normalization, and then max pooling 4 times. Okay, and then we have 1D batch concatenated with this skip connection for an extended larger version. What is this? S2? No, the link went, I don't know where. Please refer. Okay, it doesn't matter. Okay. So we have the encoder. We have the max pooling. Max pooling 1D. Do we have a max pooling 1D? Organize import. We have it. And then, so because my skip connection will be the one before pooling, so maybe after the batch normalization. Yes. So maybe we can cap skip point to append. And then we have 4 layering convolutional blocks. We need the skip.pop. This will be from the last one. So we have ending up sampling. What they refer, but ending up sampling is the transpose convolutional. Apparently not. We have there is actually one more block in here of convolutional batch. Maybe we can just create a function conblock. We have x, return x, how can I put a name indicating the encoder? Let's call it the encoder called block with the max, and then we have x let's remove the stride. Let's remove it. Stride, blah, blah, blah. And then we have to create the build decoder blocks, and then I need the skip one received in here. So we have one convolutional, one batch concatenated with the skip, and then going through 4 blocks. So I think this is probably too much, I think, but okay, let's try to see what happens. So let's put it here, the skip. We have one of these, because I don't know if maybe the upsampling is not carried out by the transpose blocks, but just by something like a dense layer. The decoder consists of 4 transpose convolutional blocks, okay, each performing nearest neighbor upsampling. Nearest neighbor upsampling. So how can I implement it? Followed by a convolution with kernel. Along the filter dimension. A point-wise convolution with k-filter. Okay, then let's read it there later. Let's see, let's try to make something similar. We have nearest neighbor transpose convolutional block performing nearest neighbor upsampling. But if I'm computing a transpose convolution, I'm not making something similar to a nearest neighbor upsampling. Or tile. I will understand. Okay. Let's nearest neighbor upsampling will be just replicating or maybe creating a mean between size 2. Repeat each temporal step size along the time axis. Instead of the convolution. What we're using here, nearest neighbor upsampling, Odena et al. The convolution and check for artifacts. Which is basically this thing. Yes. In particular, the convolution has an uneven overlap with the kernel size when the kernel size is not divisible by the stride. While the network code in principle careful learn to avoid this. Okay. So better upsampling. To avoid this artifact, we'll address the unlike the convolution, this approach to upsampling shouldn't have artifacts. Okay, our approach is to make sure that your kernel size is divided by your stride, avoiding the overlap issue. This is the equivalent to subpixel convolution. Another approach to separate out upsampling to a higher dimension for a convolution. For example, you might resize the image and do a convolutional layer. Okay, but can I do? Probably I don't have something. Repeat each temporal. How can we do it? Maybe we can color resize. Upsampling 1D, calling the TensorFlow resize, like some bilinear interpolation, something like that between the keras. No way, no? Because in the 2D there is something. Can we use the and 1D? No, 1D just repeat each temporal step size along the axis. Can we use the 2D? Here we can. Let's try this. So instead of doing the transpose convolution to avoiding artifacts, I like this. Let's upsampling. Let's put a reasonable size in here. Let's go. How do you use this size? It is 1, 2. One. So for sure, if the sizes are not going to match, let's nearest. But in this case, okay, I'm thinking how this will work, because if we're using nearest interpolation, it's going to select the value of the nearest point. So we are doing 5, window of 5. We're going to choose 2 from one side, 2 from the other side, and 1 in the middle, right? It's going to do something like this. Okay, it's not repeating the values, but more or less. Okay. Don't worry. So okay, and we have the upsampling with the nearest interpolation. Then we have one normal convolutional basically, and a batch normalization apparently. Then we have the concatenation with the skip. So we have x if skip is not null, put it, but it's not a plus, but a concatenation. Should I use the TensorFlow? No, maybe I can do like this. Concatenate. Exactly. You know what I mean? Exactly. You have the concatenate layer. I guess this is along the. So we are going to have the double of time series basically, and then convolutional and batch 2 times. Convolutional and batch 2 times. But we have the output. In the output, let's the encoder consists of 4 convolutional blocks. Convolutional iteration model preserve the input dimensionality to 0 padding. Each block in the encoder performs 2 consecutive convolutions with 5-dimensional kernel related to width 9 and max pooling. In the 4 blocks, the pooling windows are 10, 8, 6, and 4. 2 additional convolutions are applied to the fully downsampled signal. This aggressive downsampling reduce. Okay. Enforce learning abstract features. Okay. Let's see then the parameters of this for our case. But the decoder consists of 4 transpose convolutional blocks each performing nearest neighbor sampling of this input following by convolutional with kernel for transpose convolutional blocks. Is this using transpose convolutional blocks, or this is the convolution with finally a pointwise convolution with K filters. Exactly. Then we have at the end, I'm not completely sure about this. Then we have the final convolution 1G with the sigmoid, a pointwise convolution with K filter. Exactly. With one filter. Okay. Let's add also the learning rate. Maybe we can then modify. I would like to modify the losses, then maybe penalizing not only the binary cross entropy but also penalizing the change, a consecutive change, penalizing the difference between two consecutive values to reducing, if we saw that this happened, and probably yes, how to change between 0 and 1. That's okay. We have depth sum. These are transpose convolutional layer. I think they have the source code. I don't know if they have the source code. What is the? I'm going to copy this to the notebook. Build decoder convolutional block. X. Let's move this to the notebook just to see what happened, and we can delete it. Build model. With our model configuration, and let's put filter. And this is there are 10, 8, 6, and 4 pooling windows. 10, 8, 6, and 4, 10, 6, 4. Each block, 2 consecutive convolution, 5-dimensional kernel dilated to width 9. 5-dimensional kernel dilated to width 9. 5-dimensional kernels. If I understand what is saying this, what is dilated, I mean I should not the stride but the other. This is what it meant using the dilation rate exactly. So I should put 2. So this is 5 with a dilation rate of 2. And the number of filters, each block, pulling windows. Do we know this? I think we don't know this. Okay, let's put just some number. Let's change it to see if the 8, 16 to June 64. Of course it's not going to match any of the dimensions, but we can fix it. We can fix exactly. Oh, com block, filters, kernel size, pooling size. No, oh my god, it's not here, not here, not here. Let's put it just dilation rate. This is the encoder 2. Also dilation rate. Also for the decoder part, this is with kernel sizes. With 5-dimensional kernels. 2 consecutive convolution with 5-dimensional kernels. 2 consecutive convolution with 5-dimensional. Okay. Each performing network of the system followed by convolution with kernel 4, 6, 8, and 10. So this is our encoder kernel size. This is our decoder kernel size. Encoder and this is an notebook, yes. Decoder. Can we format a little bit this? No. Format cell. Or even worse. Encoder kernel size. In each case, each block consecutive 5-dimensional kernel related with 9, followed by normalization. The max pooling 10, 8, 6, and 4. So I think this is a transpose convolutional in there. And then we have the decoder kernel size. The decoder considers the transpose convolutional blocks, each performing nearest neighbor upsampling of this input, followed by something I'm not for this. Did they publish the source somehow? No. Due time. They probably they did. Due time. Models. Due time. What they are using PyTorch? TensorFlow Keras. They have, this is the encoder. So we have the convolution. Kernel size 1. Patch. Okay, we have it. Okay. Then it says, okay, this is the, exactly, that's what are we doing? Adding the residual connection. Okay, this is okay. Then we have the last part, which are perfect. Okay, this is okay. And they put names and everything. Then we have the upsampling. They use the upsampling 2D, convolutional, and batch. Maybe there is okay, this probably there are these two things, the convolution and the batch. Okay, that's perfect. And then crop nodes to match. Then they concatenate, and then we have, they are always regular convolution, so they are not using So maybe they call the transpose convolution to the fact that they are upsampling and then making the convolution. And then they have, no, not this one, filters by complexity factor. In each case, reducing the number of filters on each step. Okay, by a complexity factor, well, I don't know what that is. Do they talk about the complexity factor? No, probably something of the code, doesn't matter. Okay. No, but it's clear. Okay, there are regular convolutional blocks. We are reducing the number of filters on each step. We are using kernel size is the same kernel size everywhere apparently. It's the same kernel size everywhere, so why they say okay, at this point I'm doing whatever I want. Let's make a reasonable architecture ourselves and go. Let's put kernel size here. Kernel size, kernel size, kernel size, kernel size. Okay. This is kernel size, kernel size, kernel size. Let's use the same kernel size everywhere. This is kernel size, kernel size. Create encoder, create encoder. Okay. Self kernel size. There are default parameters for this. To do. Relation to kernel size 5. This is the pool that they define. Okay, I think we are more or less okay. This is of course not going to work. What is missing? Pooling size. What does it say here? Pooling. Beautiful. Pooling size. Okay. Yeah, probably it's too much, no? The pooling size. Let's put let's put just 2 layers, 8 and 6. Spectacle. Okay, that is probably also true because this is going to expect something like can I do a reshape? There is a reshape layer. Is this what I want? No, I want to expand the dimension. I don't want to flatten. Something like that. This is Copilot making things, but I'm not completely sure this is right. I don't like this 0 here. Let's put the pooling size 4 and 2. Okay. The input length is I'm an idiot. The input length will be something like 60. Something like this. Okay. So this trying to concatenate, but is not got it, because this is not pop in here. So we have the skip layers. Is enumerate. So if I'm in the first block, I need to concatenate with the last one, right? Len. So maybe the upsampling is not okay. Okay, can I say like this? It's going to be the same. Okay. Let me remove this just for now. We have the input layer, convolutional. It's reduced until here. Then we have the reshape, the upsampling, but we went from here to here, so this is too much. Why? Putting size 2. Pulling size 2. Why is 4? It should be 2 in here. Ah, beautiful. So we have exactly, and then we have, okay, and then we end up with the same thing that we started. So I wasn't inverting the convolutional block, so it was just using 4 and 2 instead of first 2 and then 4. So this is okay. We are reducing the dimension, upsampling using the interpolation, then convolution and batch normalization, and then build model.summary. I'm not returning the model. Okay, let's return model. And then another thing is trying to restore this. Skip. It's not. No, skip the. No, it's not Y. I need when I am in the. When I'm in the last one, where is the concatenating here? Here, okay, it's concatenating with the other one. When I'm in the first one, I should use the last one. Why it doesn't work with minus E? Because the first one is going to be minus 0, okay. That's why it doesn't work with minus E. So, okay, let's pop. Pop is going to take the last one, okay. Default last. Okay, so this is our UNet, UTime architecture. Let's call it build. Okay, let's move it here let's move it to the model. Let's call it build UTime model. Let's maybe UTime configuration. Wait, this is the okay. Then okay, I will like maybe customize this and then customize the loss. Okay, but one thing at a time. So okay, we have this. Why not? Let's remove these things. Let's see if we can parameterize all of this somehow. Maybe via YAML or something similar. And then we have the dataset loading. Let's load the dataset first. We have the, for now let's hard code everything. I'm calling them, let's call the model, let's call fit. Let's add, if we want, the early stopping. I will remove the plot losses. I will change the class weight. Also something I would like maybe to, let's comment it here, to parameterize the class weight. If we want to put more weights in the positive class instead of the negative, since we have less positive than negative, that is something I would like to parameterize also. And then we just save our model at the end, and then we should write this code a bit better. Okay, let's load data sets, exactly, return, maybe we can just dataset path. Do I have a, okay, this return exactly. No, from typing import tuple. Okay, we have low data sets. Maybe we can just also, maybe I should change the name. Let's rename symbol low data set configuration. Maybe we can return everything in here, not only this, but the dataset configuration, and then let's compile that. No, can I do something like this? Okay. Then we have load data sets, we have train DS, val DS, test DS, dataset metadata. This configuration, I don't know why, but we're not using it. Train data set. But batch size should be also something to put in the parameters. Let's train configuration, the early stopping patients, batch size, all the things that we are going to pass. Okay, let's see if this works. And the daytime for saving the model. From data import time logger, so we have, let's put up the class weights as optional. then I will need the model configuration. This is everything I will need. Let's see if we create a simple architecture also, and then maybe we can have two, and then a logger. So let's just try like this, and then the idea is to use later, after we have everything set up, some tool for tracking experiments, so we can have a bit more information about the things to use, which layers, the sizes of everything. So otherwise it's a bit difficult. Okay, how do I use typer exactly? I would like to do something like this in main. Main train. Then we can also save the history. Let's put to do everywhere to do save history. Oh, we can do it. Let's. Why? Just one. Then you can save not only the figure but probably everything. Let's. Okay. Exactly. The data path mode. I would like to create a folder instead of this. Let's put output path. Something like this, and then I need the evaluation also. So, okay, output path. Let's create. I will create everything in here, but then probably we should split it because everything is in CLI. No, I will remove everything from here. Save results. What do I need? The model itself. The history, maybe the history I can take it from the model. Okay. Logger. Then I would like to save the maybe we can. I would like to save also the history in raw as a JSON maybe. Then I need to save the test results and the model itself. But okay, one step at a time. No get that crazy. Let's go, and then maybe I can create a module called like train in which I put all of these functions. So okay, let's try this. We don't have anything basically. Just training this model. Let's 10, 8, 6, 4. Why not? Let's clear this. UV, I should install it again. I can create in the Pi project the CLI train main. Error while resolving setting from workspace. Okay, then. No. Oh, okay. PH set train model. UV run. What is my data set? PH set data, df data sets. Okay, I have only one. Okay. In the concatenation 75, 32. It's maybe because it's something regarding to the division of the sizes. No, it's not completely 10, 8, 6 and 4, which is, what is my size in here? Maybe the 6, exactly. Maybe, can I pour something like this? But I should do, like, the length should be power of 2. What is my number? 6,000. 6,000 times 10. 8, 4 and 2? No. Can I repeat? Oh, I probably should calculate. That's why they were like cutting the time series for matching the dimensions. No, 92 and 93. So, okay, let's try what we have it at the beginning. Maybe we can try to figure out some numbers to put. Okay. Let's see, everything works. Oh, it's really slow. Why is that slow? Oh my god. It's actually using, yes, the GPU. Why is that slow? That is something really odd. What is the thing slow? Let's also write the summary in here. Let's increase the batch normalization. What is the thing that is slow? Because otherwise there are convolutionals, a few convolutionals, okay, but not. Why so slow? How about if I remove the batch normalization layers just to Is the upsampling. Let's remove the brain here. The upsampling layer. It shouldn't be the upsampling layer. Why that slow? Nearest. Pulling side filters. Is there a way for profiling? Oh, I guess there are a lot of convolutional layers. I don't know what to say. We have the sampling, reshape, a few convolutional, normalization. It's not. I don't have the greatest GPU, but exactly. Do I need the dilation rate? Why is so slow with the dilation rate different to one? Well, maybe because you can use the optimized kernel, right? Extremely slow on CPU, but also in GPU. Maybe I can increase the mask, like put it 9 instead of blah blah blah. Can you take a look? Maybe I should use the 2-dimensional. Maybe I have to use a 2-dimensional convolutional layer. The recall is going completely down. It's predicting everything almost 0. Oh, not everything, but yes, everything's 0. That's the other thing I saw of the progress bar of Keras. Why is doing this? Yes, it's predicting everything almost 0. Really nice. Okay, at least we have this thing going. Let's just, for the sake of testing, but I have to reshape, no? One like this. With dilation rate 2, let's reshape it before, let's reshape it after. Not support between chapel and int. Dilation come to D. What does it say? Dilation rate. Come to D. Dilation rate 1, 2. see the summary. I would like to build your time model. This is a string or is printing on a print the summary of the network? Because it's before fitting, not after. Okay. So we have a one encoder block. We create this thing. We create the. We make the convolution with the dilation rate. The dilation rate, I think, is 1. I put 1, 2. I think it's okay. Where are we? Here. The thing that we have to do is figure out what to put in the upsampling and downsampling so we can have numbers that match, and then play a little bit with the sample weight or the class weight or something like that to avoid collapsing in a zero prediction model, where we can compute how much 1 or 0 do we have in the data set. Maybe I can leave this model running. I think that and we have to finish the parameterization with some YAML and some experiment tracking for later. So I cannot. Let's 8, 4, 2, 4, 8, 12. And then this thing. Why is that? I don't know. If I do this, I should find an error. 14 and 15. I don't know I don't know exactly. Let's try where the difference came from. If it's from the upsampling, let's import, and let's put here. The first one is 14, the second one is 16. So the first one is concatenate is our current layer, and the skip layer is the one that came from the other side. So if I put just one, it's working. If I put two, it's not. Can I in the upsampling data format interpolation nearest the upsampling factor of rows and columns? Can I like pad or something in case there is zero padding 1D? cropping. Cropping 1. How many units should be trimmed? But the fact is, should I trim or should I pad in here? Because the skip is the second one. So the skip is probably the right one. So in this case, I should pad this instead of trimming this. Upsampling to the. But it's always the case if I put, for example, 10. It's always less. It's always less. Let's try to 0 padding 1D. 0 padding 1D in the X layer. But when the shape, if X shape, how much I would like to pad is the difference, basically. Can I do this? Do I have the refresh concatenate? Exactly. So maybe I can do always modifying this one, cropping. Cropping 1D. If the skip is bigger, I pad. If a skip is smaller, I crop. Well, I think it makes sense. Let's just print this to see what we are dealing with. Model. $72. Because this is but this is how many zeros to add at the beginning and at the end. If two, how many zeros to add at the beginning and at the end. So I can do like this. Let's put the difference equals blah blah blah. Maybe we can use difference over 2. This time is a bit more hacky than before. Claro, and then it's not enough. Interesting. Cropping 1D. Okay. So we were talking about artifacts. It's going to produce 1,000 artifacts probably. Yeah? Now it's bigger. So I say, how much should I? This should be a proper way to do this. Zero padding, cropping. So I would prefer actually to be always bigger and cropping. No, what I can do is like this. Okay, let's see. If exactly else it's the shittiest thing in the world. So if we have, if it's not completely the same, so what is happening here? We are interpolating. So I would prefer actually to do something like this and crop it instead of padding with zeros, to be honest. But again, in this case it's going to be way bigger. No, why it's so small in here? No. Upsampling 1D. Oh, this should be in the same thing, no cropping. But if I put so I think I should do this more or less the same in here. But I would like to know -4, -3. Yes, you're right. Difference should be like this. Reconoce que un peso problema de mamma mia. Cropping. Can I print the shape? Print. No, it's way bigger. No, I don't like it. Oh no. Okay. I'm not completely happy about this, but ensure shapes, something. No, ensure shape will be ensure matching shapes. It will be our skip layer. Let's put it in here. What can I do? Okay, but at least if we run it now, we should have our thing going, and we should have in some place the reshape, normalization, upsampling, concatenate, zero padding here. Okay. So we are upsampling there, we are missing two things, adding zeros, two samples, okay. So, okay, we have model. I will try to read the paper a bit more carefully later, but I think we have this model. I would like to create just a simpler model with not the skip connection, just a few convolutional layers reducing the dimension, a few transpose convolutions for making the for reconstruct the time series at the end to see if we actually something like this. We actually win something by creating this unit or not. Let's put it in here. Def build com model. Something like this. Probably this is just the same. I can use this, maybe yes. Let's model configuration. The learning rate shouldn't be here, maybe yes. Input length, maybe we can restructure. So we're going to need some model architecture configuration, training parameter configuration, and maybe some model compilation configuration, losses or something like that. Let's see. So we have conf, input length. We are going to have for without using strides, without max pooling, maybe even without batch normalization. Then maybe we can add it as an optional. Let's call it. Let's rename this u time comb block. There we have for going backwards, basically like this. Strides. And then we can have then the other one like this, with one filter, one. Okay, not that terrible. And then we return the model. And this is TF Keras model. Or Keras model, no? Directly. Yes, just a model. I hate this progress bar. Okay, and then we have the two models, one a bit more simpler, let's say, and the other one a bit more complex, but with the same philosophy both. We have some configuration objects to build them. Okay, later I will try to read the article a bit more carefully, and I will stop now, but in the next video for me, but probably it's going to be published in the same YouTube video, loading the configuration file here, and then after that we can attach to some experiment tracker thing, and then we can have to define a few experiments to run it, and then we can compare the results. But I don't know in which point I should create this post-processing of the events. But okay, at least I would like to have the training script finished. Maybe after that, the post-processing, so we can create the model evaluation module a bit more comprehensive. And then finally attach to a tracker experiment and run the experiments. For now I will leave this running. Let's see what happens. And I would like to try to figure out what is going on with the progress bar. But okay, for now it's okay.